Okay, today we need to review mins and maxes and how to write an equation for something like this. I'm just going to do a really quick one for you. Let's say that I had this. What's the difference between the -3 and the +4? And wait a minute, those are opposite of what I said. The -3 is the root. Remember, the root is not a 3. The root here is -3. The factor has an x plus 3. Anyway, this root and this root, those are the x-intercepts, the roots, the zeros. These two roots do different things. In the picture, in the graph, what would one of them be doing that the other one wouldn't be doing? Yes. It would be a bounce. Yes. So if I was going to make a picture, if I find the -3 and I know that my equation bounces right there, could it be bouncing from below? Yeah, sometimes they bounce from below. Sometimes when it's squared like this, they're bouncing from above. So then you got to ask yourself, okay, if I give you the equation and you have to make the picture of it, how do you know whether it's bouncing this way or bouncing that way? It's really hard to tell. You got to start with your end values. So the really, really smart thing to do on all of these is to start by figuring out your lead term. Do you get the lead term would not be an x squared? Because if you multiply this out, it'll get bigger than that. It'll actually be an x to the third. Does it actually have any number on the front of it other than a 1? Then that's your lead term. Hold on just a second while I pause. Okay, so if I've got a root that's at -3 and it's bouncing, then again, it could be like this, could be like this, but I can't tell. I got a root at 4 and it's not bouncing. That's over here. And there's a dot and it goes through, but I can't tell if it's going to go through this way and end going down or go this way and end going up. But wait a minute, actually, I do know that, don't I? I know it's going up. Why do I know it's going up like that? Yes. There is no negative on this lead part of the equation. You are correct. Okay. So since I know it's going up, then do you get it must be bouncing that way? Also, the other end value, I know it has to be going down here. Why do I know it has to be going down there if it's going up over there? Because it has an odd one. All right, so sketching these, if I say here is an equation. I'm going to make this, I'll just keep it simple for your first one. And I'm going to add one more twist. Alert. There's a negative in front. Okay, I want you to sketch what you think this thing looks like. I'm going to pause for a second while you do that. I'd also like you to answer a few questions about it. What's its lead term? What's its lead coefficient? What is its right end doing? What's its left end doing? Gentlemen, I hope you're talking about math back there. All right, right end, left end, and let me think. Lead coefficient, lead term. Any other topics that we covered and I'm not thinking of right now? Oh, I know. Where is it? Oh, you won't know where it's increasing and decreasing because you have to know the maxes and mins, and you won't know where they are. You might know it kind of looks like this, but you don't exactly know how high it is or, like where this spot is. Oh, you actually know one of your local maxes. How about that? I'll just say if you know a local, not local, we called them relative, thank you. Last year we called them local mins. It's the same idea. So if you hear me saying local min, it means relative min. Relative min or relative max. It might have one of them but not the other. Write that out. And I can't do the increasing decreasing thing because you don't know exactly what the other max is. So I'll do a different graph to do that. All right, try answering those red questions and sketching the blue equation. All right, I'm going to pause while you do that. So one flaw with my plan is that if you don't get how to sketch it, then a lot of the other things can't be answered. So by now, how many of you have got a sketch that you think is right? All right, if that's stumping some of you, then let me help you get started on that. Because at least if I give you the sketch, then you'll be able to answer the rest. 5 is important. -3 is important. I'll make those dots red. They're that important. Those are really, really important. And then it's going down on the right, so you know it has to be going through this way. Next, it's bouncing at the 3, so you know if it's up here, the next time it touches is at the 3, so it has to bounce off of that and be going up there. That means now you should be able to answer all those other questions. And I'll pause for a second. Now, I know you don't know exactly where this spot is. Okay? If I tell you that spot, which I will, I'm going to say that that's at 1, 4. But then, you'll be able to answer 2 more questions. Increasing and decreasing. Where is this thing increasing and where is it decreasing? And hint, one of them happens twice. It's either increasing in 2 different spots or it's decreasing in 2 different spots. Okay? Obviously, it's increasing sometimes and decreasing sometimes. I'm just saying it's either increasing twice in 2 different areas or it's decreasing in 2 different areas. And you might say, well, I don't know this point. Yeah, you do. You know that point. Okay, I'm going to pause again while you give that one a shot. Go. Okay, so to answer these questions, the lead term, I hope you get how to multiply these puppies out. This is really important. X squared, and this one's just an x to the 1, and this negative all get multiplied together, and you get negative x to the 3rd. That's the lead term. That's what should be here. I think you've got this. How many of you have got that? Raise your hand if you've got that right. Okay, good. Then we'll go on to lead coefficient. It's a number. A coefficient is a number. It's the number in front of this. There is no number, but I'm going to put a 1, -1. Next up, the right end. The right end of this function is this area, and that appears to be going down. And that's because of this negative. Then the left end is either the same as that or the opposite of that. Since this is odd, it's the opposite of that, and it's going up. Next up, relative min. This spot right here is a low spot, and that is the relative min. You just list it, and it's at -3, 0. If you just said -3, it would have been marked wrong, because I don't know what that means. Does that mean x is -3? Y is -3? What is it? Is it like the answer to how many, what's your golf score today? I'm 3 below par. Anyway, you got to label it. Next up, relative max. The relative max is, I told you what this point was, and I hope you realize that was a relative max. And it's at 1, 4. Why do you think I didn't even put absolute max or absolute min? Because we don't have them. This thing goes up forever, so there's no max. This one goes down forever. Over here, it's going down forever, so there's no min. No absolute min. But these are, relatively speaking, minimums and maximums. Last thing, increasing and decreasing. It's increasing once in the green zone here. In that zone, it was increasing. And that's, do the x values. If this spot here is at -3, 0, the x values would be -3 to 1. I'm curious how many people had that one right. Okay, that's a little less than half the class, so I get that might be one of your weakest spots. And then, decreasing. It's decreasing in this red zone here. That, I'll just do them one at a time. That red zone is from 1 to not negative infinity. They're x things. And the x that's over here is infinity. 1 to infinity. It's decreasing from 1 to infinity. Notice we never use brackets on those. We'll just always use parentheses. I did tell you that this is one where you could argue that they're brackets versus parentheses, but it's really tough to argue with Schoology when it marks them all wrong. Just to use the parentheses, okay? All right. Then, decreasing. Another spot it's decreasing is right there. You might say, but it's got an up arrow. But we read from left to right, so it's decreasing in there. So that's from over here, which is where negative infinity is, up until the -3. So negative infinity to -3 in a parenthesis. And what's supposed to be between them? A union symbol. Very good. Easy to forget that. there's two things. It's this and that, and that's the math way of saying and, is this little union symbol right there. And again, it's putsy, but do you really want to lose 5% off your test grade just for a missing U? Because that's what would happen. If everything else was perfect and all I forgot's the stupid U, I'd probably only take off 5%. Especially if it's a multi-part question, okay? If this was the only thing was where is it decreasing, you could lose the whole credit for the problem based on just that U being missing. Okay, so learn all the little details to do it really right. All right, next thing I'd like to do is find the file that's posted for today. Today is 11-30, and that file will look like this. So I'd recommend me pausing until I get everybody there. All right, so today it's about factoring. You might be saying, but we already know how to factor. We factored a lot. Good. It's good to know how to do basic factoring. But we are going to be factoring things that are much harder than before. Okay, this is what we did before. This is what we're going to do now. Now look at the difference. It's got an x to the fourth in it. Never factored anything like that before. Okay, so let's start with this one, the one that you know how to do. Everybody, start by looking to see, is there anything that goes into everything? It's called the GCF. So if you've sucked at factoring, you really got to step it up now, because you got to get your basics down right now, because then we're stepping up into higher level factoring. All right? So yeah, there's a 3 in everything. Everybody get that factored out and see what you have left. Don't try to go right to 2 parentheses. Just get the 3 out of everything first. Then you can go to 2 parentheses. And I'm going to pause for a minute while you fight through this. And actually, I think it'd be a good idea to do partners today. So right now, I'm going to pause for a second while you slide next to somebody, because you're going to need a little help now and then. So again, I got you all moved into groups now. So now I recommend that you try to get this factored all the way down, and don't solve it. It never said to solve. Oh, wait, I'm wrong. Look at the end of it. Then identify its zeros. Okay, so I guess you do solve it at the end. So the reason you factor is usually to solve it. I didn't see the word solve, but identify its zeros, that means solve. As in set the y equal to 0 and solve it. X must be this and x must be that. All right, pause while you work on that. Okay, here's how this should have gone. The 3 comes out, and then you have x squared minus 2x minus 8. Then, hopefully you notice that that can get factored again. I have an x and an x to make the x squared. And then, what do I need here and here? So that, and I know some of you are going to say, so it multiplies to 8 and adds to 2. It's better to do the outside and the inside and make that come up to negative 2x. But I know when the lead number right here is a 1, it will work to say multiplies to negative 8 and adds to negative 2. Either way, did you figure out what it was? Okay, 4 and 2 make an 8, and 4 and 2 can make a 2 also, right? So I'm going to go with a 4 and a 2. And which one's negative? The 4. And the way you know for sure that this worked is to watch this outside-inside thing. Negative 4, positive 2, add them together, you get negative 2. That's the safest way to do it. Those of you that do the whole multiplies to this, adds to that thing, that's going to get screwed up when there's a number here. Like, let's say there was a 2 right there. That doesn't work anymore. You got to do my outside-inside thing if you get a number in front like that. Okay, we didn't in this case. It would have worked in this case. Final answers, x equals negative 2, x equals 4. Raise your hand. How many groups had that done? Okay, good. So, how does it get more complicated? That. Well, don't think that, oh my gosh, it's got a 4th and there must be some hugely different way to do it. Nope. It's actually pretty much the same. Is there anything that goes into all of them? That is always your first step. Look for the GCF, because in the most complicated ones, there's something in everything and it has to come out to the front. In this one, it's actually a baby one because we're starting you off on your first x to the 4th. We want it to be impossible. When you send a hunter out for the first time, they're probably not going to send them out to catch a mammoth. You're going to start out going for squirrels or something. All right, so anyway, this one's not too tough. If you put an x and an x, are you possibly going to get x to the 4th? No. Do you think logically that we would want to do an x to the 3rd and x to the 1? No, probably not. What do you think? X squared, yep, and x squared. So everybody start with that and just figure out the rest. You'll know if you're right by multiplying it back out. I'm going to pause for a second. It's just like the other kind. Don't think it's like totally different. It's not. You just got to find a number here and a number here so that this thing multiplies out right. I'm going to pause. We'll give that a try. So here we go. I would hope that you guys figured out that the same kind of deal, it has to multiply to 8 and somehow make a 2, and there's no number in front here, so that little trick would work. So I got a 4 and a 2, and it's pretty much the same thing, except this time the 4 was positive and the 2 was negative. Raise your hand if you got that one right. Awesome. But did you notice that it said, then find the zeros? All right. So this is what's going to make this assignment a little harder, is you have to actually solve these things now. What do you mean solve them? And before I just used to take the other number and say the answer is 2. The answer is not 2. What you really have to do here is say x squared minus 2 is equal to 0, and x squared plus 4 is equal to 0, and solve them. So you get problems now that will have like 9 steps. Step 1 is factor it. Step 2 and 3 is to make 2 equations out of these. Step 4, 5, 6, 7, 8, 9 is to solve it from there. All right. Do you remember how you add 2 to both sides and you got x squared equals 2? Do you remember how you take the square root of both sides and you got, don't just say one answer. Absolute value of x is square root of 2. Remember that deal with the square root of a squared? Square root of a variable, I mean. And then the final answer over here is x equals negative square root of 2 and x equals positive square root of 2. Whew. Expecting a lot out of you, but hey, you signed up for an honors class. This would not be done in the regular class. I'm not saying they don't factor hard stuff, but they don't factor nearly as difficult stuff, and they also don't have to solve it. So this is the step-up part where you say, okay, I can handle this. I've done this before. Subtract 4, x squared equals negative 4, and then this one's even going to have imaginaries. Square root of a negative, it's not that hard, just say 2i. Absolute value of x is 2i. Then you got to make 2 things. X equals 2i, x equals negative 2i. This is what I made the top 20 for, because all these little steps, like if you by now have practiced your top 20 and it's no big deal to make an absolute value, then this part's easy. If you've been avoiding that this whole time, thinking, oh, I don't really need that top 20 stuff, well, then you're going to suck right now. It's going to really be difficult to handle all the algebra. Final answer, negative square root of 2, positive square root of 2, 2i, and negative 2i, and I hope you can tell that those are the imaginary ones because they have an I in them. Why do I have 4 answers? Because I've got a 4 for a degree. Thus, I must have 4 answers. Okay. That's tough stuff. Heavy duty. On this next one, I'm not going to do it with you. I'm just going to remind you that all of these had a GCF that would have come out first. Before you even started, what would you have done on part B? Factored out, yes? Factor out the 2. And then you would have just done the exact same thing as last time. All right, moving on to this one. A little weirder. Let's see who knows what to do first. I'm going to pause just for a moment to see if you can figure out the first step on this thing. Because once you get the first step down, it's actually easy. You see it? Take out an x. Yes, there's an x in everything. X comes out. X squared plus 6x plus 9. And then that just factors like a nice easy one. But the catch was you had to factor an x out first. Finish the job. Let's see who can finish this for me. The dice of destiny say that row 6, person 1, all the way over there. So, you got it factored? Nice. Now, let's get the actual imaginary and real answers. So I say equals 0. Now I can tell these are just going to be easy ones, and a lot of kids are going to say x equals -3 is the only answer because it's the same thing there. That's actually not possible. There's supposed to be 3 answers. See? It says 3. Now, this is kind of cheating, but x equals -3 makes the second answer. Ah, that's cheating. What does that mean? That means it's a bounce there. It's a double root. That's 2 of my answers. But what's the third answer? He sees it. 0 is correct. That guy needs to also be set equal to 0. Really, this is saying x plus 3 equals 0. X plus 3 equals 0, and x equals 0. So x equals 0. There's my third answer. And I know it's kind of cheating to say this is 3 things, but this is called a double root. Yes? Yes, and you would have still had a double root of -3. Because if I'd have put these together and said squared, I still have to solve that. And my first step would be to take the square root, and then I'd have to blah, 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 blah. And the square root of 0 is 0. So it's going to be plus and minus 0. And that's going to mean that it's just one answer. Because plus 0 and minus 0 give you the same answer. Yes? Yes, this has to be -3 twice. Now, if a kid had just written down these 2 answers, I would have said, okay, I'll give you the credit because I know one of them's there twice. On the graph, it has to be -3 twice? Yes, because what does it mean to be twice? It means a double root. It means a bounce there. Okay, anyway, so I need to get into the different kind of factoring now. This kind, all that really happened is that you have to be able to factor out something from everything. Let's do this hardest one here. D as in dog, D as in dolphin. Factor something out of everything, and then you're still going to be left with some more factoring to do. Yes, as long as you get it factored all the way, I don't care how many steps you do it in. Some people do it in like really quick in one step. They factor it a whole way. It's okay. It's legal. But I like to do it in 2 steps. 4x comes out of everything. And then I like to do the next part is this part breaks up into 2 parts. All right, I'm going to pause for a sec while you give that a try. Okay, by now you should have got the 4x out of everything. X squared. Is that a plus or a minus? Minus. X squared minus 2x plus 1. And then it factors again. X minus 1 and x minus 1. Does that make sense? Now I got kind of 3 answers, but kind of like 2 answers. This one's x equals 1. This one's x equals 1. This one, 4x equals 0, is just x equals 0 again. To make this part equal 0, just set it equal to 0 and solve it. 3 answers, but it's kind of like 2 answers and one's a double. Okay, cool. Now, this new thing. It said right here, all the polynomials we factored have had 3 terms. If we have more than 3 terms, we need a different method. One such method is grouping. All right, I call this the divide and conquer method. It's got 4 terms. What you do is divide it down the middle, factor just this side, then factor this side, and then I'll tell you what to do. Act like it's 2 separate problems. Divide and conquer. It's a classic military strategy. If you can divide their army into 2 parts and take on only 1 part at a time, it's way easier because they're weaker, because they only got half their guys. So, anyway, we're going to separate this into 2 divide problems. I'm going to pause while you give that a try. Okay, maybe you don't know what I mean. This part has an x, in fact, it has an x squared in both parts. I'm not even looking at this right now. Just looking at this. They both have an x squared in them. So I pull the x squared out, and what do I have left? X plus 3. Awesome. Then I start looking at this part, which is completely separate, and we factor it. What comes out of both of those? 2. And then what do I have left? Do you think that's a coincidence that they both have an x plus 3 in them? No, that's not a coincidence. Now, this part's going to blow some of your minds. To finish the deal, I have to factor what's left. This and this both have something in common. X plus 3. It gets factored out to the front. And what do I have left when I take them out and I take out my x plus 3's? Technically, what I'm doing is dividing by x plus 3 here and dividing by x plus 3 here. That's what you're doing when you are factoring something out. So that makes this cancel and this cancel. And what's left? X squared plus 2. Congratulations, that's the most complicated factoring that you've ever done. That's called factoring by grouping. That's the final answer. I hope that, yeah, it's kind of, I find it kind of satisfying, kind of fun. It's not that hard. The key moment was right here. Once you factored out stuff and there was something in common right there, these will be in common or something went wrong. Okay, and if those are in common, they just go to the front. Just like you do with any other factoring, you pull it out to the front. Like here, I pulled the x squared out to the front, right? So at this moment, I got to pull the x plus 3 to the front. And then once I pull those out, what I have left is x squared plus 2. All right, let's do another one like this. Factor by grouping. Divide and conquer. Divide that puppy right here. Notice that negative sign needs to be on the 8. That negative is owned by the 8. See if you can do it. I betcha, even after only one example problem, at least half the class can do this. This is not that hard. I'm going to pause for a second while you give this a try. Okay, so on this first one, there was an x squared in both of them. Of course, that's the harder one to factor. That's like baby factoring. I just have to factor an 8 out. But if I factor out the wrong thing, those parentheses won't match. Let me show you what I mean. I get this factored in. Do you get an x plus 3 again? Yep. Okay. Over here, if you factor out just 8, it's going to get messed up. Because if I just factor out an 8, do you get I'll have x minus 3 here? And that doesn't match. If they don't match, then you did it wrong. So instead of taking out an 8, who figured out a way to do that? Yes. Negative 8. Negative 8 comes out, and then you have x plus 3, and that's what I needed. Those are the same. Final answer. X plus 3 comes out to the front. X squared minus 8. And then find all the zeros. I know it's a pain, but that's my factoring. Now here's how I find the zeros. I set it equal to 0. This part's easy. X equals negative 3. Hey, I got one of my roots really easy. But how many roots are there supposed to be? 3. So now I got to solve this part. X squared minus 8 equals 0. X squared equals 8. I just added 8 to both sides. Okay, now, how do I get that solved? Square root, square root. Do I know the square root of 8? No, but I can simplify it. And that's an absolute value. And that's root 4 and root 2. You really should always do it with 2 square roots first, because kids classically will say this is like 2 root 3 or 3 root 2, and it's actually 2 root 2. Then I split it up into 2 answers. X equals 2 root 2, and x equals negative 2 root 2. That's one answer. That's 2 answers. That's the third answer. I know there's 3 answers from this, and there's my 3 answers. Is there any I's in my answers? No, then therefore there were no imaginaries. That's one of the things on the test. They're going to say, did this have any imaginary roots? And sometimes kids go, oh, it had square roots, so there was imaginaries. No, if there's square roots of negatives. So there was no imaginaries here, because there's no negatives under the square root. Okay, you've learned everything you need to know. Now, let's take a look at the worksheet. Everybody find the worksheet posted for today. Thankfully, it's not a Schoology quiz. There was like 4 of those in a row. And I am going to cut this down. Now, I'm going to ask you to be mature about this. I'm going to say you should do the odds. But if you're terrible at factoring, you really should probably pick up a couple of the evens too. If you know this is your kryptonite, then you should practice more. Okay? It's odds unless you need more. Some of you know you should do more. At a minimum, do the odds. Number 1, number 3, etc. All right, so let's start number 1 together. What do you think? this one of those kind where something factors out of everything? No, but you should always check for that, because that's the trick on the hardest ones. Then this is one of those kind where I can put x squared and x squared, and from there it's not going to be that bad. Who could finish the deal? X squared, what? And then x squared, what? 36 is a beast because there's a lot of things that go in it, but anybody found it yet? 9 times 4 makes 36, and a 9 and a 4, can they make a 13? I think a 9 and a 4 could make a 13. Okay, so it's probably a 9 and a 4. Oh, and that's going to work really nice too, because one of them is going to be a perfect square. But anyway, one of them's negative. Which one's probably negative? The bigger one or the smaller one? Both. Why? Because I need 2 negatives to multiply to make this positive 36. Cool. And then, do you see why the teacher did this? They set this up really nice, because now it factors again. What? Because those are perfect squares. So then it's x plus 2 and x minus 2 and x what? Plus 3 and x minus 3. There you go. Now the cool thing is I've got all 4 roots really easy to see and solve. I don't really have to say x minus 3 equals 0, add 3, add 3. I could probably just say x equals 3 in my head, couldn't I? So I can get my answers pretty quick because it factored down so much. But remember, if later in this worksheet it says like x squared minus 3, you're going to have to set it equal to 0 and solve it. This kind, pretty easy because it doesn't have that. But it's your first problem, so it makes sense. All right. Now, I think by now you should be able to answer, well, we already got factored form, obviously. The zeros ought to be easy to do in your head. Number of x-intercepts. That means, does this touching in 4 different places? Yes, it is, because there's 4 different roots. Do you get that if you have an x plus 3 and an x plus 3, it only touches in 1 place? See what I mean? If this had come out to like this, 2x plus 3s, that's only touching in 1 place. Okay, so then that would change your number of x-intercepts. All right, again, I just changed the problem to show you something. It does not have a plus there. So number of x-intercepts is 4. Yes? Which one's factored form? This one's the one that's factored all the way. So that goes up here. You can just draw an arrow out there. It's fine. Oh, good question. If you left it this way on the test, I would mark it wrong for sure, because it's not factored all the way. It's kind of like this. If I say reduce this fraction, and the fraction is like 400 over 200, and the kid says, okay, so 40 over 2. Well, that's reduced, but it's still not all reduced all the way. Same with factoring. If you don't factor it all the way, it's wrong. You haven't reduced it all the way. This really should be 20, which is way better looking than that. All right, that's all I got for you for today. Do the odds, just the odds. And I think we're going to grade this one in class tomorrow because I have 2 classes that have subs today. So I want to really make sure that people actually do their homework. We're probably going to not have me grade it. You can submit it to the Dropbox, but we're still going to grade it in class tomorrow. That's all I got for you for today.